the mouse acute spinal cord injury model, we found a summatory synergy. We did this at our lab at the University of Michoacán, Morelia, Mexico. As we know, the ASHA classification of spinal cord injuries are graded from A to E. A and B are the severe lesions that normally, even that the same ASHA association put the guides clinical management for spine injury. As you can see, the quality of evidence for all of them are very low, only moderate for the use of methylprednisolone in the first 24 hours, excuse me. And the strength of the recommendations is very, very weak. Even though surgeons, neurosurgeons or orthopedics are more preoccupied for bone and not really for the lesion at the nervous tissue. The reality, the actual prognosis of these lesions are even death or in higher levels, quadriplegia or paraplegia. Since the first years of the 20th century, in 1914, Cajal and his colleagues did experimental lesions and study the degeneration and possible regeneration of them. Even they did a peripheral nerve interposition on a spine section in rats that produces growing of neurites. Right now, in the last 40 years, we have done a lot of investigations about why is the problem to regenerate the spinal cord. Some investigators, like Sofronio in San Francisco and Kursian Bradke in Germany, have proposed that there is different things that it is necessary to regenerate spine injury. One is a trophic influx from near cells to axons. Schwann and other cells like stem cells, but I want to name the enchytic olfactory glia that also has a very big trophic influx that produces chemiotaxis and elongation. Intrinsic neuronal genetic responses have been studied at peripheral neurons, but it seems to be sleepy at central neurons. On the other hand, there are many ways of sprouting of synaptic circuits through injury sites and requiring plasticity. On peripheral axons, there are principally a lot of different responses than in central axons. The first is that there are special receptors for trophic factors and is a quick signaling retrograde to the body of the neuron that begins a genetic process and a proteomic response to stabilize the microtubules and produce finally a cone of groove that will let the axon to regrow and reconnect. But in central axons, there's no that genetic response. It seems to be sleepy, and the first very big problem is that the cytoskeletal of all the microtubules are degenerated, are broken, and that produces the retraction bulbs or degenerative bulbs that are impossible to reconnect functionally. Blanky and Bradke at Germany have proposed Paclitaxel like an agent stabilizing the microtubules in a very lot of experiments. Most in vitro have demonstrated that that functions. We have done some works with colchicine, and also even colchicine has a contrary action of Paclitaxel in microtubules. Colchicine in very low doses have the severing of actin filaments, and it is also necessary to the progression of filopodium of the glucons. On the other hand, Chandran, at a very large study at the University of California and other centers, did in 2016 a very big and important study looking for genetic expression of ganglion neurons when they are injured. They map all the genes activated, up-regulated or down-regulated, and also with that information and with bioinformatic analysis of these signaling meshes associated, look for drugs that could produce more or less or resemble the same action. They found that ambroxol upregulated and downregulated most of the signaling meshes associated. And they use it in experimental analysis with ambroxol on models in vitro of ganglionar cells injured and in vivo experiments of optic nerve sections in mice. As you can see here, this is the mapping of the upregulated and downregulated genes when the neurons are injured and when you used ambroxol over them. And in the experimental optic nerve sections, they see clearly a difference with ambroxol producing more numbers of neurites growing and far away more large distance from the crush site. What can we say about enchyting olfactory cells? They have been investigated for many people groups, principally at Spain, and they can say that these special glial cells produces a lot of neurotrophic diffusible factors and a lot of proteases, and both are very important to let the growing of the axons lesion at the spine. With that antecedents and background, we decided to make our study with a mouse model of total section doing laminectomies at thoracic level T8, T9, and we did total section with scissors and a severe contusion with impactor with high weight and graded to 100 kilodynams. That resembles the A and B lesions in the classification of ASHA. Our animals were assessed to different groups. We have a sham group of 10 animals. In that animals, we only did the laminectomy without any kind of lesion. In the other control group, we did section with no treatment. In the other, severe contusion without treatment. And we had 5 groups of experimental animals and with different therapies associated. In the first, only the grafting of olfactory bulb, the transplantation of olfactory bulb. In the other, the application only of 2 drugs, Taxol and ambroxol. In the third, 3 drugs, Taxol, ambroxol, and colchicine. And the last 2 were the association of olfactory bulb grafting plus 2 or 3 drugs. The time and application of drugs for the animals are illustrated here. We did the initial basal 3B evaluation of motor action. BV is the basal BD and Bresnan scale that is the largest used in this kind of experiments. At the time of injury, we applied the first doses of Taxol and colchicine, and at the first week, we repeat the second doses of Taxol and colchicine, and also done the first motor evaluation. The grafting of olfactory bulb was at the same time of the injury. I have to say that it is heterologous olfactory bulb from mice donors. The doses of Taxol and colchicine are here. As can you see, colchicine is at very low doses comparing to the doses of Taxol, that letting that Taxol acts more over the microtubules, and colchicine in very low doses acts more in microfilaments of actin. Ambroxol was done during the first 10 days daily. In the first 5 days, we used a higher doses and diminished to the half of the initial doses for the last 5 days. The motor evaluations with the BBB scale was done, as I said, basally and in the first 2, 4, 8, and 12 weeks on an open field arena, also with video and video tracking analyzed with ToxTag program. And this is our results. As can you see, the sham group There's no any motor deficit, even in the first week to the 12th. They maintain the 21 value that is maximum of this scale. And you can see that section without treatment, the control group, has a minus evidence of motor. The animals were paraplegic clinically, but with minors and reflexes movements of the tail that progress probably only 2, in some animals to 3 in the scale of 21. But you can see all the treatment groups. In all, we have results since the first week. And at the second, 4, they elevated. And finally, at 12 week, we have the best results with the association of grafting of olfactory bulb and Taxol, ambroxol, and Taxol, ambroxol, colchicine. When we consider not only complete section, but also contusion, like we call spine cord injury in general, that resembles more or less a clinical panorama, we can see that have results less worst in the group of control, but they maintain a clinical paraplegia with some movements of the tail that are more reflex and the hind limbs. In the other groups, we have in all results, but very considerable, the recovery of the animals with the combination of grafting of olfactory bulb and 2 and 3 drugs, Taxol, ambroxol, and colchicine, had the best results finally at 12 week. As an example, I can show you the tracing of the tox track program at 12 week of a sham animal that is no lesion. The section group with no treatment, an animal that has movement like Morse with only front limbs and are totally paraplegic. The contusion that also produces paraplegia, but a little more movement and a little better results. But when we evaluate our grafting animals with 3 drugs, we have, even in section, a lot of movement with 4 limbs. Only we notice spastic tails in most of them. And in contusion groups, the recovery was much better, as you can see. We did studies, histologic studies of all the spines at 12 week after sacrificing the animals, and we did H&E, Niesel, and Cajal-Golgi's impregnation. As can you see, we evaluate gliosis, reactive gliosis, the presence of atrophic neurons, and the number of neurites crossing the lesion site. In sham, as you can expect, all the neurons are normal and all the neurites are intact. But when we see sections, we saw a lot of reactive gliosis, even no neurons, normals, and no crossing neurites, the site of lesion. As we can see in other groups of treatment, we can see that the grafting and the association of grafting and drugs are much better results with less reactive gliosis and more neurons conserved and neurites crossing. As an example of NISL, we can see the results here in an animal with grafting with 2 and grafting with 3 drugs. As can you see, lot of normal neurons, lot of glial cells, non-reactive, and probably this can be more of the glia grafted. In Golgi, we can see neurites crossing the site of the lesion. This is an animal of total section. And with our results in analyzing with transmission electron microscopy, we saw 4 degenerative lobes and grade of myelination. In the control group with section without treatment, a lot of degenerative lobes and no grade of myelinization. In other groups, we can see less degenerative lobes and more degree of myelinization, and the best results are with the combination of grafting with 2 or 3 drugs. As an example, I show you the micrographs with a sham. This is a sham animal. This is a section without treatment. This is a contusion without treatment. And this is grafting with 2 and 3 drugs associated. As you can see, the degree of new neurites that are little in diameter and begins myelinization. And with this, we did an analysis of myelin that we can see here in red, and quantifying the signal of that. And we can see that in the section where we associated the grafting and 3 drugs, Taxol, ambroxol, and colchicine, we have in the mean of 15% of myelinization at the 12th week. This is one of our best results in the association of grafting and 3 drugs with a lot of myelinization and a very lot of new myelinated fibers. That means regeneration. In conclusion, we can demonstrate a summatory effect of using olfactory bulb implantation, more 3 systemic drugs, Taxol, ambroxol, and colchicine. We reach great motor recovery on the animals. They can walk on 4 feet and can stay on the hind limbs. And we demonstrated histologically the basis of this motor recovery. We proposed that this combinatory policy for acute treatment of spinal severe injury has to be adopted soon on clinical phases 1 trials. This is our publication, and this is the reference that is open access, and you can see our complete work right there. For attention, thanks.
Thank you very much, Carlos Torres. And as we all know, that traumatic spinal cord injury is a very devastating event that frequently has disabling outcome and economical burden on society as a whole.